So we'll continue the topic how to write a chemical formula. As we discussed yesterday, that when we are writing a chemical formula, what we have to look for? We have to first look for the symbol as well as the valency. So if it is group 1, it will be plus 1, group 2 will be plus 2, group 3 will be plus 3, group 4 is minus 2, group 5 minus 3, group 6 minus 2, group 7 minus 1, and group 8 is 0. So if I say write a chemical formula for calcium chloride, what will be the chemical formula of calcium chloride? The chemical formula for calcium chloride. Calcium chloride. So first you have to find a symbol for calcium, which is Ca, and then you have to find for chloride or chlorine, that is Cl. So first what we do, we write the symbol calcium is Ca and chloride is Cl. Then we write their valency. Calcium belongs to group 2, so it is plus 2, and chlorine belongs to group 7, it is minus 1. And after writing the valency, we simplify. How we simplify? We cross multiply, take a simplest ratio, but 2 is to 1 is already in the simplest ratio, so we cannot further simplify. So we simply cross multiply. The 1 of chlorine will come with calcium, and one of the and the valency of calcium will come with chlorine, so it will be CaCl2. That is calcium chloride. Is it clear? This example to everyone. Yes, Saim. Is it clear to everyone? Another example, if I say write a chemical formula for aluminium oxide. So what will be the chemical formula of aluminium oxide? Aluminium is in group 3, where oxygen is in group 6. What will be the chemical formula for aluminium oxide? You can use the chat to state the answer. The valencies are there. Group 1 is plus 1, group 2 is plus 2. Yes, Abdullah, that's right. So when you're writing a formula for aluminium oxide, aluminium is Al and oxygen is O. When you write the charge, the valency, aluminium belongs to group 3, so it is plus 3, where oxygen belongs to group 6, so it is minus 2. Then it is 3 and 2. We cannot further simplify. It's already in the simplest ratio. What we do, we cross multiply. So 3 of aluminium will come with oxygen and 2 of oxygen will come with aluminium. So the formula of aluminium oxide will be Al2O3. Is it clear to everyone? Yes, Yusra, Afreen, Bashira. Is it clear? Okay. Then what about the elements which are present here? They are not in the specific group, and we call them as a transition element. So how you will write a formula which include a transition element? So it's very simple because their group is not mentioned. So as they don't have a specific group, in the name they specify their charge. Like example, if I say I have iron and in a Roman number I write 3 and then oxide. So iron 3 oxide. When I find the position of iron here, this is iron Fe and oxygen is O. I know oxygen belongs to group 6, so oxygen is -2. We know the symbol of iron, which is Fe. We know the symbol of oxygen. We know the valency of oxygen. As we know its group number, it's group 6. But what about iron? Because it's not in a specific group. So how we know the valency or the charge? So this Roman number is actually showing the charge of this element. So it's Roman 3 is written. So if Roman 3 is written, what is the charge of iron? The charge of iron is plus 3. So for these type of elements, as their group is not specific, in the formula, in the name, they specify their charge. Like it can be 3, 2, 4, 7, any number, depending on how many electrons it transfer or share. So in this case, iron 3 oxide, so what it shows iron is having a charge of 3 plus or plus 3. So what we do, we cross multiply. It can be positive or negative, but because these are metals, and for metals, all the metals, they should have positive. So in this example, because it's about the metal and all metals have a positive charge, so it will be positive. Then we have to simplify. How to simplify? Take a simplest ratio, 3 is to 2. It cannot be further simplified. So what we do? We cross multiply. So when we cross multiply, it will be iron Fe2 and O3. So the formula for iron 3 oxide is Fe2O3. Is it clear? Is it clear to everyone? The formula of iron 3 oxide. So for these elements, it's much easier to write the formula compared to other, because for other elements we have to first check their group and write the valency. But for this type of elements, the Roman number which is written next to the element is actually the valency of that element. Another example, if I say I have iron 2 oxide, iron and then Roman number 2 and then oxygen is their oxide. So what we do, we'll write the symbol for iron, which is Fe, and we write symbol for oxygen, then plus 2, and this will be -2 because oxygen belongs to group 6. Then 2 and 2 can be further simplified as 1 is to 1. So when we cross multiply 1, so it will be FeO. Capital F, small e should be there because the symbol of iron is Fe. So iron 2 oxide, the formula of iron 2 oxide is FeO. Another example, chromium 6 oxide. So how we can write a chemical formula for chromium 6 oxide? So first we have to check, this is chromium, so symbol of chromium is Cr. And then we check oxygen, symbol of oxygen is O. It's not necessary that oxygen should be there always. It can be any other element, but I'm giving you example, a simple example. That's why I'm taking the same element. So chromium is plus 6 and oxygen is minus 2. Can I simplify 6 and 2? 6 is to 2. Can be simplified into. So I can simplify, I can divide both of them by 2. So this will be 3 is to 1. So basically this will be 3 and this will be 1 when I take a simplest ratio. Then after taking a simplest ratio, we cross multiply. 1 will come with chromium and 3 will come with oxygen. So chromium 3 oxide formula will be CrO3. Is it clear? This example of chromium 3 oxide. Is it clear to everyone? The formula of chromium 3 oxide. So chromium 6 oxide basically, not 3. It will be CrO3, but the name is chromium 6 oxide. Then there are certain for chromium 6 oxide. Look, the symbol of a chromium is Cr and symbol of oxygen is O. This Roman 6 is for chromium, so it means chromium is plus 6. And oxygen, it is minus 2. So one of the valency is 6, another valency is 2. So 6 and 2 we have to further simplify. So I divide by a smallest number, which is 2. So this will be 3 and 1. So the simplest ratio will be 3 is to 1. And after simplifying, we cross multiply. So 1 is written with oxygen, we'll write with chromium. And 3 is written with chromium, we'll write with oxygen. How would we know the Roman number? You have to learn the Roman in mathematics. You are learning the Roman numbers like 1, 2, 3, 4, 5. In maths, you have studied this 6, 7, 8, 9, and 10. This is in mathematics. You have to learn the Roman number for first 10, like 1 to 10. Learn these symbols which represent the Roman numbers. So 1 is with oxygen, it will come with chromium, and 3 is with chromium, it will come with oxygen. Yes, Abdullah?
Sir, how would we know that which Roman number will come after the symbol? It can be even 1, it can be even 2.
That they will specify, that they will mention in the question. Like chromium 6 oxide, they will ask to write a chemical formula.
Okay, sir.
Yes, I do not understand well about this. Look, what you have to do, Saim, the question is write a chemical formula for chromium oxide. Saim, I want you to use the mic so that at the same time I'll clear your doubt. So it is written chromium 6 oxide. Yes, Saim, use your mic. It's written chromium 6 oxide. So first we'll find chromium. What is the charge of the chromium,
Okay, sir.
Saim? What is the charge of chromium?
52.
Chromium 6. It's written Roman number 6. So this Roman number represents the charge. So what will be the charge of chromium?
6.
6. And oxide means oxygen. Oxygen belongs to group 6. So group 6, what is the charge of group 6?
-2.
Minus 2. Then the second step is we take a simplest ratio. What is the ratio of 6 and 2? How to take a simplest ratio? We divide by the smallest number or common factor. So when we divide by common factor, smallest number, so this will be 3 and this will be 1. So the simplest ratio of 6 and 2 is 3 is to 1. Is it clear now?
Yes, sir. Now it's
And
clear.
then what we do, we cross multiply. What? So 3 is written with chromium, we write with oxygen, and 1 is written with oxygen, we write with chromium. So the formula for chromium 3 oxide is CrO3. Is it clear?
Yes, sir.
Another example, if I want to write nickel 3 chloride. So what will be the formula for nickel 3 chloride? You can use the chat to state the answer. Nickel 3 chloride. This is first the symbol for nickel, Ni, and for chlorine or chloride it is Cl. The formula for nickel 3 chloride. Nickel 3 chloride. That's right. Nickel, first we write the symbol. Nickel is Ni and chlorine is Cl. Because this 3 is for nickel, so it is plus 3. And chlorine belongs to group 7, so it is minus 1. So one is plus 3, another one is minus 1. We cross multiply. So it will be NiCl3. So nickel 3 chloride, the formula will be NiCl3. So if element is given from this part, if any element is given from this part, they will ask or they will give you, they will ask for the formula, but they will give you the valency. But sometime you have to work out the valency of the element from the formula. You can work out the valency, like if I say the formula of a compound is, even you can use a periodic table for that, but if I say a compound is CuCl2, so what is the valency of Cu and what is the valency of Cl? So it's just a one step away. How we work out the valency of Cu? So as we cross multiply, because normally what happened, the valency of the copper is multiplied with chlorine and the valency of the chlorine is multiplied with copper. And the element which is written first will have a positive valency and element which is written at the last will have a negative valency. So it is written CuCl2. So this 2 is actually the valency of copper. And here nothing is written, it means it is 1. So minus 1 will be the valency of chlorine. Is it clear? So it can be reverse. They can also ask in another way, that they will give you the formula and they can ask for the valency of that element. Is it clear? So sometime a formula is given, they can ask for valency, and sometime the valencies are given and they ask for formula. Same way, example, if I say I have a compound FeI3 and the question is what is the valency of Fe and what is the valency of iodine? Can you work out the valency of iodine and iron? Yeah, that's right. For iron, because the number which is written here with iodine is actually the valency of iron, and the number which is written with iron is actually the valency of iodine. And the first element will have a positive valency, and the second element will have a negative valency. Is it clear? Anyone having a doubt? Abdullah Khan, Afreen, Sain, Isra, Sira, anyone? Okay. Another thing, there are certain ions which are written not mentioned in the periodic table. So there are certain ions or molecular ions which are not shown in a periodic table. So you have to learn or memorize the valency for these ions. Not too many are there, so you have to learn or memorize the valency. So what are those? Hydroxide, nitrate, nitrite, sulfate, sulfite, carbonate, phosphate, hydrogen carbonate, and ammonia. So hydroxide, nitrate, nitrite, sulfate, sulfide, carbonate, phosphate, hydrogen carbonate, and ammonium. You have to learn the formula as well as their valencies. So for hydroxide, so I want everyone to copy this table at the same time. The hydroxide, it is OH, and the valency is -1. So copy this table at the same time so you can have a record of this. For nitrate, it is NO3 with a charge -1. For nitrite, it is NO2 with a charge -1. For sulfate, just I will use a short space so that I can write each separately. So hydroxide is OH with a valency -1. Nitrate is NO3 with a valency -1. Nitrite is NO2 with a valency -1. Sulfate is SO4 with a valency -2. Sulfite, it means SO3 with a valency -2. carbonate is CO3 with a valency -2. Phosphate is PO4 with a valency -3. Hydrogen carbonate is HCO3 with a valency -1, and ammonium is NH4 with a valency +1. Yeah, this is important. This will not be given in exam, and you have to actually memorize the valencies, because without memorizing the valencies of these molecular ions, you cannot answer the question or complete a formula. I will give an example as well, like what cases. So it's very important that you should learn or memorize these valencies. So if I say what is the chemical formula for example calcium hydroxide. So the question is chemical formula of calcium hydroxide. So calcium is there. You can check the periodic table. When we see or check the periodic table, you can find the calcium in a periodic table as the calcium is a group 2 element. So you can clearly see in a periodic table. And what is the charge or the valency of the calcium? The charge or valency is +2. But what about hydroxide? You don't find hydroxide in the periodic table. So that's why we know the calcium, but we don't know hydroxide. So as we know calcium, for calcium we write Ca and the valency is +2. Hydroxide, it's not from periodic table, that you have to memorize. So hydroxide is OH, so we write OH. And what is the valency? -1. Now the rule is the same. What is the rule? That we simplify the valency and then cross multiply. So this one, yeah, this one is written with calcium hydroxide, so we'll write with calcium, and this 2 is written with calcium, so we have to write with hydroxide, means with both carbon with oxygen and hydrogen. So how we write this? So we write Ca calcium and then hydroxide, put in a bracket and then put 2. Why in a bracket 2? Because it means this 2 is with oxygen also and this 2 is with hydrogen as well. Is it clear? The chemical formula of calcium hydroxide? Is it clear? Yes, Abdullah.
Sir, why did we put bracket?
Why we put for example, we don't have to simplify that. Basically, what happened? It will be CaO2 and H2. Okay, because if 2 is multiplied with oxygen, it will be oxygen 2 and hydrogen. But we don't have to simplify this. That's why a rule is there. Without simplification, we just write the valency with the ion. So this 2 is actually the valency of calcium and 1 is actually the valency of hydroxide. Is it clear?
So
We
what's
don't.
the reason of putting the brackets?
The reason of putting a bracket, because for example, if I write like this CaO2 and H2, so you may not be able to recognize this that it is hydroxide. But when you see CaOH in a bracket 2, from this OH you can clearly identify that there was hydroxide. The only reason is to make it simple and easy to understand directly when you look at the formula.
Can't we write CaOH2 without the bracket?
If you write CaOH2, it means that this 2 is with hydrogen only, not with oxygen. But when the cross multiplication occur, when we cross multiply this 2, so this 2 is coming with both hydrogen and oxygen. That's why we cannot write only with hydrogen.
So this bracket rule only come with this 9
Yeah,
elements.
this bracket rule is only for these 9, not elements, actually these are called molecular ions. So like group of atoms are there which have charge. So this rule is only, bracket rule is only for these molecular ions. For the simplest one, like if you are writing aluminum oxide, so you don't have to write, put in a bracket. Is it clear?
Yes, sir.
Another example, the reason why I'm erasing this part so that I can use this valencies to explain the second example. If I say write a chemical formula for aluminum nitrate. So first thing, aluminum is Al. We write Al. Then we have to check the valency of aluminum. How to check the valency of aluminum? We will use a periodic table for that. So when you see the aluminum, it belongs to group 3. So what will be the valency of aluminum? That will be plus 3. So aluminum valency is plus 3. Then we will check for the second nitrate. Nitrate is NO3. And what is the charge? Nitrate is NO3 with a charge -1. So this is -1 and aluminum is +3. The valencies are already simplified. When the valencies are already simplified, so this 1 will come with aluminum and this 3 will come with NO3. So when I write the formula, what will be the formula for aluminum nitrate? Al, then NO3, the nitrate ion, in a bracket 3. Is it clear? The chemical formula of aluminum nitrate. Yes, Abdullah.
Sir, the 3 after the O is the charge of oxygen.
Which 3? This one? And O3?
Yes.
No, no, this is not the charge of oxygen. This shows the number of oxygen atoms present in nitrate. So nitrate actually contain 1 nitrogen and 3 oxygen. And the charge is -1 on this whole. And aluminum charge is +3. So when we cross multiply, after simplifying, this 1 will come with aluminum and 3 will come with nitrate. So it will come out as aluminum 1 and there is NO3 with a 3 particles. Is it clear?
Yes, sir.
Is it clear to everyone? The formula for aluminum nitrate. Abdullah Khan, Saim. So same way, we can write a chemical formula for different compounds as we did now for aluminum nitrate. Another example. So it's very important that you memorize the charge. If I say I want to write a chemical formula for calcium sulfate. So first I have to check calcium using a periodic table. Calcium belongs to group 2. So its charge will be +2. And sulfate is SO4, as you can see in this table. Sulfate is SO4 with a charge -2. The second step is simplify the valency because it's 2 and 2, which can be simplified as 1 and 1. So this will be 1 and this is also 1. And 1 and 1, so we just cross multiply. So this will be CaSO4 bracket 1. But bracket 1, we don't have to specify. I told you when it is 1, it is obvious. So instead of putting a bracket, you can write without bracket, because I can write CaSO4, or if I write CaSO4 1, that does not make any difference. So chemical formula, when we represent, if it is written 1, we do not write a bracket. Is it clear? We just do not represent or draw a bracket to show the valency. If I want to write a chemical formula for sodium carbonate, so writing a chemical formula for sodium carbonate, so first we'll use the periodic table. Sodium is Na with a charge 1 plus, and carbonate is CO3 with a charge -2. So what we do, we cross multiply. It is already simplified, so when it is simplified, we cross multiply. So this 2 is with carbonate, come with sodium, and this 1 is with sodium, will come with carbonate. So Na2 CO3. And in a bracket 1 does not make difference, that's why I did not make a bracket. So if it is 1, we do not draw the bracket or write the ion in a bracket, we just simply write as it is. If it is like 2, 3, 4, then we write the or show in a bracket. Is it clear? The second example, the sodium carbonate. So I'll share another link and continue this discussion of how to write a chemical formula. It is very important that in chemistry, from the name, you should be able to write a chemical formula of the compound.